This is the first question that people ask when they start learning about astronomy. In this video, I'm going to tell you why the sun rises in the east and sets in the west. You already know the answer, right? So, here goes. The Earth rotates on its axis from west to east. The Earth's rotation makes it appear as if the sun were rising in the east and setting in the west. For that, we need to go back to the beginning. As it collapsed, it started spinning faster and faster. Remember that the matter in this cloud was originally spread out and moving in random directions? Or why large-scale air currents circle around the globe the way they do? Or why ocean currents rotate in different directions in the northern and southern hemispheres? These are all examples of the Coriolis effect. The Coriolis effect only becomes noticeable over long distances and long time scale. The Earth's rotation causes the sun to appear to rise in the east and set in the west. As the cloud collapsed, angular momentum had to be conserved, which gave the Earth its initial spin. Without the Earth's rotation, these phenomena wouldn't occur. So remember, the next time you watch the sun rise or set, or if you're caught in a hurricane, to thank the Earth's rotation for the show. While this may or may not be true, physics is definitely a highly mathematical subject. But even if you're not going to study physics or math at university, having a good understanding of math is extremely useful. There's nothing more frustrating than wanting to understand something and not being able to because your math skills aren't good enough. It is a great introduction to the subject and covers everything from vectors and matrices, to systems and linear equations. And if you're interested in learning more about algorithms, their Advanced Algorithm Fundamentals course is a great place to start. It covers topics such as big O notation, sorting algorithms, graphs and trees. The Coriolis effect is another consequence of the Earth's rotation. With thousands of lessons available, you're sure to find something that interests you. Plus, their interactive lessons are a fun and engaging way to learn. So if you're ready to give Brilliant a try, so don't wait. Start learning today and see how much you can accomplish. Thanks for watching and learning with Brilliant. Are there other factors that could be causing the sun to rise in the east and set in the west? Let us know in the comments below. And don't forget to subscribe for more fun science videos. Brilliant is an online learning platform with thousands of lessons in science, computer science, and mathematics. They offer courses ranging from beginner to advanced levels. So, whether you're a student trying to get a better grade in math class, a professional looking to brush up on your science skills, or just someone who wants to learn more about the world around them, Brilliant has something for everyone. It also causes large-scale atmospheric phenomena like hurricanes and ocean currents to rotate the way they do. They make learning math and science fun and engaging with interactive visualizations and follow-up questions. One of my favorite things about Brilliant is their focus on practical application. A lot of traditional math classes can feel very abstract and theoretical, but Brilliant courses are always relevant and applicable to real-world situations. For example, their logic course teaches you how to think critically and solve problems using everyday examples. Their Algorithm Fundamentals course uses visuals and interactive puzzles to help you understand how algorithms work, which is essential for computer science and many other fields. If you throw a bucket of water a few feet across your room, you won't notice any current. However, when large-scale phenomena such as hurricanes and ocean currents are involved, the Coriolis effect can be very important. So as it started to collapse, all that angular momentum had to go somewhere. You'll throw the bucket straight north. Due to the Earth's rotation, the water in the bucket will appear to deflect to the right. From your point of view, it looks like the water starts to curve to the right after you throw it. But from the point of view of someone who's standing still relative to the Earth, the water just goes straight north. So what is really happening is that the Earth's rotation is causing the bucket of water to curve to the right. This apparent curving of objects that are moving on the surface of the Earth is caused by the Earth's rotation. It's called the Coriolis effect. It couldn't just disappear. That would violate the conservation of angular momentum. Angular momentum is conserved. This means that the Earth got a little spin from the collapse of the cloud. Imagine a huge cloud of gas and dust floating around in space. This is what our solar system looked like before the sun formed. All the matter in this cloud was spread out randomly and moved in random directions. But what causes the Earth to rotate in this way? Does the sun play a role? No, of course not. The sun doesn't care about how the Earth moves. It just sits there radiating light in all directions. As they pull in their arms, their spin gets faster. As the cloud of gas and dust that would eventually become the sun collapsed, all the angular momentum in the cloud had to go somewhere. Some of it went into the sun, but most of it went into the Earth. That's why the Earth has a slight bulge at the equator. There's also another interesting phenomenon related to angular momentum called the Coriolis effect. This is because angular momentum is conserved. Before they pulled in their arms, they had some angular momentum. After they pulled in their arms, they still have the same amount of angular momentum, but is concentrated in a smaller space. Therefore, they must be spinning fast. If you're not spinning right now, try pulling your arms in and you'll see that you start to spin. Conservation of angular momentum is at work. But wait, if the sun doesn't cause the Earth to rotate, then what does? Now, for some reason, this cloud started to collapse. Let's take a look at another example. Have you ever seen a figure skater pulling in their arms while spinning? Okay, so back to the sun. Have you ever wondered why hurricanes rotate in the northern hemisphere counterclockwise and in the southern hemisphere clockwise? Imagine that you're standing on the Earth's equator with a bucket of water. If the Earth didn't rotate, then nothing would happen. But since the Earth does rotate, the Coriolis effect comes into play. So why does the sun rise in the east and set in the west? It's because the Earth rotates on its axis from west to east. Before the Earth and the sun formed, the matter that would eventually make them up was part of a huge cloud of gas and dust that was spread out over a large area. The Coriolis effect causes large-scale phenomena such as hurricanes and ocean currents to rotate the way they do. Do you think there's anything else that might be happening here that we haven't considered? When I was in college, one of my professors used to say that 90% of physics is math, and the other 10% is making the math correct. In today's video, I want to tell you about Brilliant, the sponsor of this video. I've been using Brilliant for several months now, and I'm constantly impressed by the quality of their lessons. One course I've been enjoying recently is their Introduction to Linear Algebra course. So whether you're really looking to brush up on your math skills, or you want to learn more about the science behind solar energy or artificial intelligence, Brilliant has something for you.